Assalamu alaikum. Myself is Dr. Farzana W from Chemistry Department, J.A.T Arts Science and Commerce College, Malegaon. आज हम देखेंगे FYBSc का फिजिकल केमिस्ट्री पेपर फर्स्ट CH101 और कंटिन्यू करेंगे हम. बिफोर दैट वेलकम ऑल ऑफ यू. We will continue here with chapter Ionic Equilibrium. As we have seen in the previous section, what is mean by the electrolyte, what are the types of electrolyte, what is mean by degree of ionization or degree of dissociation, and also we have seen the various factors which are affecting the degree of ionization and dissociation, and also we have discussed about the dissociation constant of acid and dissociation constant of the base, which are designated with the symbol Ka and Kb. Today we shall discuss about the buffer solution. What is mean by buffer solution? An aqueous solution which resists a change in pH on addition of a small amount of an acid or base is called as buffer solution. ऐसा solution जो solution के pH को change नहीं होने देता on addition of acid or base is called as buffer solution. It is necessary to have a solution in many purposes of chemistry, biology and industry whose pH should not change as much even on addition of appreciable amount of strong acid or strong base. Such solution is called as buffer solution. There are two types of buffer solution, acidic buffer and basic buffer. These acidic buffers are the solution which maintain the pH of value less than 7. Whereas basic buffer, these are the solution which maintain the pH value greater than 7. As we have seen in the previous section, what is mean by pH scale? We write from left 1 to 14. 7 सेंटर में आता है, 7 मतलब न्यूट्रल, less than 7 acid, more than 7 bases, and on that basis you can say that ऐसा बफर जो pH वैल्यू को 7 से कम मेंटेन करता है उसे एसिडिक बफर कहते हैं, और जो pH वैल्यू को 7 से ज़्यादा मेंटेन करता है उसे बेसिक बफर कहते हैं. These buffer solution are prepared by mixing two solution in such a way that they contain two species of conjugate acid or base pair. You will be better understood with the help of example in which way acidic or basic buffer prevent the change in pH of the solution on addition of acid or on addition of base. So पहले हम देखेंगे acidic buffer and its mechanism. Acidic buffer are made by mixing an aqueous solution of weak acid with solution of its salt with strong base. For example, equimolar mixture of aqueous solution of acetic acid and sodium acetate. It may be prepared by mixing the acetic acid and sodium acetate equally. They are called as acidic buffer. And it exists the equilibria as acidic acid dissociated. यहाँ पर थोड़ी सी मिस्टेक है, प्लस की जगह क्या रहेगा, एरो रहेगा. Acetic acid dissociated into acetate ion and H plus ion, whereas sodium acetate dissociated into acetate ion and Na plus ion. So the mixture contained relatively high concentration of both acetic acid and acetate ion. Note that this is an acid and its conjugate base. These can be considered as reservoirs ready to react with added OH minus and H plus ion respectively in neutralization reaction. ये इक्विलिब्रियम रिएक्शन को ध्यान में रखिए कि इसमें क्या मिलता है हमें, एसिटिक एसिड से एसिटेट आयन और H प्लस आयन, और सोडियम एसिड से क्या मिलता है, एसिटेट आयन और Na प्लस आयन. when we add the acid, the H plus ion of acid combined with the acetate ion and to form the undissociated acetic acid. In this way, it removes the most of added H plus ion effect on the solution. जैसे ही हम एसिड ऐड करते हैं उसका H प्लस आयन एसीटेट आयन के साथ मिक्स होकर क्या देता है, एसिडिक एसिड। इस तरह से H प्लस आयन जो है वो यूटिलाइज हो जा रहा है विद द हेल्प ऑफ एसीटेट आयन। इसलिए H प्लस आयन का सॉल्यूशन पे असर नहीं होगा और इसीलिए सॉल्यूशन का pH जो है वो चेंज नहीं होगा। ऑन एडिशन ऑफ बेस, the OH minus ion of the base combined with acetic acid। सॉल्यूशन में क्या क्या है, एसिटिक एसिड भी है, एसीटेट आयन भी है, H प्लस आयन भी है और Na प्लस आयन भी है। जैसे ही हम बेस ऐड करते हैं तो बेस का OH माइनस आयन कंबाइंड विथ एसिटिक एसिड एंड form acetate ion and H2O water molecule, removing most of the added OH minus ion. Acetic acid plus OH minus ion, it gives the acetate ion and H2O water molecule। तो इस तरह से OH जो आयन है वो एसिटिक एसिड के ज़रिए रिमूव होता है और कन्वर्ट हो जाता है वाटर मॉलिक्यूल में। एसिटिक एसिड का H प्लस आयन कंबाइन विद दिस OH माइनस आयन एंड प्रोड्यूस द H2O वाटर मॉलिक्यूल। Hence, the added acid and base are used in these reactions and they do not persist in the acidic buffer solution, and so pH does not change significantly. Okay, this is the simple mechanism of acidic buffer. Now consider the basic buffer and its mechanism. Basic buffer are made by mixing an aqueous solution of weak base with solution of with strong acid. For example, the most popular example of basic buffer is the equimolar mixture of the ammonia weak base with ammonium chloride, salt of weak base with strong acid। तो बेसिक बफर किससे मिलकर बनता है, ammonia and ammonium chloride। Ammonia is a weak base, ammonium chloride is the salt of weak base with strong acid। Now, it exhibits the following equilibria: NH3 plus H2O। NH3 को वाटर में जब डालते हैं तो वो किस में डिसोशिएट होता है, कन्वर्ट होता है, अमोनियम आयन एंड OH माइनस आयन, NH4 plus and OH minus ion, whereas ammonium chloride NH4Cl dissociate into NH4 plus and Cl minus। In this way, in the solution, both the NH4 plus, Cl minus, OH minus and NH3 are present। अब बोलोगे कि NH3 क्यों प्रेजेंट रहता है, क्योंकि NH3 is a weak base, it dissociate feebly, that means ions of the ammonia in the solution are less, whereas anionic form are more। Or you can say that NH4 plus and OH minus ion are less, but NH3 are more because it is a weak base। So, the mixture containing relatively high concentration of both NH3 and NH4 plus. Note that this is a base and its conjugate Hc. These can be considered as reservoirs ready to react with H plus and OH minus ion respectively in neutralization reaction। Now, what happened when we add the acid into this basic buffer solution? तो solution में अगर basic buffer है तो क्या होगा, when we add the acid, the H plus ion of acid combined with this NH3 to form NH4 plus, इस तरह से क्या होगा, एडेड H प्लस आयन रिमूव हो जाएगा, यूटिलाइज हो जाएगा with the help of NH3 and it is converted into NH4 plus. And when we add OH minus ion, that means when we add base, the OH minus ion of the base is combined with NH4 plus to form NH3 and H2O. ये किससे कंबाइन हो जाएगा, जैसे ही हम बेस ऐड करेंगे तो उसका OH माइनस आयन किससे कंबाइन होगा, NH4 प्लस आयन से। तो NH4 प्लस और OH माइनस आयन क्या देंगे, यहाँ पर रिएक्शन में देखो दिख रहा है, ये क्या देंगे, लेफ्ट हैंड साइड में जाएंगे रिएक्शन, NH3 and H2O molecule. Hence the added acid and base are used in this reaction and they do not persist in the basic buffer solution, and so pH does not change significantly. Now salt hydrolysis. Salt hydrolysis. Hydrolysis of salt is reverse of neutralization reaction. In neutralization reaction, it involves the combination of acid and base to yield the salt and undissociated water molecule. Whereas in hydrolysis reaction, salt leads to the formation of acid and bases in the presence of water. न्यूट्रलाइजेशन रिएक्शन मतलब क्या, ऐसी रिएक्शन जो एसिड और बेस के दरमियान होती है, और हमें मालूम है एसिड और बेस कंबाइन होकर एक दूसरे से न्यूट्रलाइज होकर क्या देते हैं, सॉल्ट और वाटर देते हैं। तो लेफ्ट हैंड साइड में हमारा क्या रहेगा, एसिड बेस, राइट हैंड साइड में क्या रहेगा, सॉल्ट एंड वाटर। लेकिन हाइड्रोलिसिस क्या है कि सॉल्ट और वाटर के मॉलिक्यूल जो है वो देते हैं क्या, एसिड एंड बेसिस, and this is called as salt hydrolysis, or you can define as the phenomena of interaction of cation and anions of salt with H plus and OH minus ion by water yielding acid and basic solution is known as salt hydrolysis. That means H plus और OH minus ion के interaction से इन वाटर मॉलिक्यूल यील्ड करता है एसिडिक एंड बेसिक सॉल्यूशन इज नोन एज सॉल्ट हाइड्रोलिसिस. To study the hydrolysis of salt, it is convenient to divide the salt into 4 types. That means hydrolysis of salt divided into 4 types. First type is salt of strong acid and strong base. For example, KCl, NaCl, KNO3, Na, NO3, etc. and etc. Hydrolysis of salt of weak acid and strong base. For example, KCN, sodium acetate, Na3PO4, Na2CO3, sodium carbonate, etc. and etc. Salt of strong acid and weak base, for example NH4Cl, C6H5NH3, Cl and CaCl2, NH4NO3, etc. And fourth type of hydrolysis of salt is salt of weak acid and weak bases, for example the ammonium acetate and ammonium cyanide, etc. Thank you for watching. Allah Hafiz.